Okay, so hello everyone. So in this video, we're going to discuss the other technique in getting the volume of a solid of revolution. So in the previous method, ang diniscuss natin ay yung method ng washers or discs, kung saan ang kinoconsider nating rectangular strips ay perpendicular to the axis of revolution. This time, ang technique naman na i-discuss natin is yung method of cylindrical shells, wherein ang kinoconsider naman natin ngayon is rectangles which are parallel to the axis of revolution. Okay? Now, as the name implies, we're going to make use of cylinders. So, in the previous method, circles yung ginamit natin. Dito naman ay cylinders. So, i-recall muna natin ang volume ng isang cylinder. The volume of a cylinder is given by pi r squared times height. So, we will be making use of this as the basis for deriving the integral, which will give us the volume using cylindrical shells. Okay, let us first consider an arbitrary sketch of the graph of a region na ire-revolve natin and kukuha natin ng volume using the method of cylindrical shells. Ganito yung region natin. And let's say for this one, ire-revolve natin siya about the y-axis. So, as mentioned, we're going to make use of rectangular strips which are parallel to the axis of revolution. The axis of revolution is the y-axis, so we're going to make use of vertical rectangles. Okay, so what happens here is yung each rectangular strip, i-revolve natin about the y-axis. So, magkakaroon tayo ng mga ganitong cylinders. So, yung una is we have something like this. Yan. We have something like this. Okay, top view nito. So, top view. Okay, let's say we want to find the volume of this particular cylindrical shell. Now, i-assign natin yung mas maliit na cylinder as having a radius of R1. Tapos, yung mas malaki, gawin natin ang radius niya ay R2. Okay, so technically, the volume of this entire thing would be the volume of the bigger cylinder minus the volume of the smaller cylinder. So that would give us V equals pi R2 squared. This is the radius of the outer cylinder. Yung height niya, notice na parehas naman sila ng height. So I will just write this as h. Tapos, we subtract the volume of the smaller or the inner cylinder. They have the same height. Okay, so the volume of this particular cylindrical shell is given by this. As I've said, parehas yung height nila. So we can actually factor out pi and h. And then we're left with R2 squared minus R1 squared. Okay? Now, we will make use of the fact that this part here is actually a difference of two squares. So, lagay ko na lang dito. Adjust ko yung sulat. Pi h R2 squared minus R1 squared. So, difference of two squares yan. Pwede nating i-factor out as R2 plus R1 times R2 minus R1. Okay, then let's just multiply this by 1. Pero yung 1 na yun, isusulat natin as this form. So, multiply this by 2 over 2. So, this is technically 1. It will not change the value. And then, yung 2 sa numerator, isasama ko sa pi h. So, 2 pi h. And then, yung 2 sa denominator, isama natin dito sa part na to. So, we have R2 plus R1 over 2. And then, R2 minus R1. So, 2 pi h. This part here, that's actually the average radius. And then, ito naman is yung change in radius. So, pwede natin isipin to as delta R. Okay? So, in terms of the measurements involved, we have the height, we have the average radius, tapos itong delta R, technically, this part here pertains to the thickness. No? So, yung delta R dito sa ating illustration, yung top view, ito actually ang delta R. So, ito yung kailangan natin in getting the volume. So, in getting the volume, what we need is the definite integral from a to b ng 2 pi times height times radius times thickness. Okay, yung thickness, it's normally yung delta times yung variable natin. So let's consider this first example. Find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is revolved about the y-axis. Kung mapapansin nyo, ito yung same region na kinonsider natin dun sa discs or washers. Okay? So what we're going to do, i-drawing muna natin yung visualization natin bago natin ipakita yung itsura niya using GeoGebra. Okay, visualization natin. Okay, we're going to revolve this about the y-axis. So our axis of revolution is vertical, therefore we're going to use vertical rectangular strips. Okay, when revolve about the y-axis, it would look something like this. Okay? And then, pakita natin using GeoGebra. Yung graph would look something like this. Yan. Now, let's view it from this part. Yan. So, ito yung hahanapan natin ng volume. Okay, again, the volume is given by definite integral from a to b 2 pi ang height, radius, thickness. Okay, since we're going to integrate using vertical strips, yung limits of integration natin would be yung limits sa x-axis. So, definite integral from 0 to 3, 2 pi. So, yung thickness natin would be delta x. Yung height, this pertains to the height of each cylindrical shell. Now, yung height naman ito, it's not complicated kasi technically, it will pertain to this part here, no? Which is just f of x. So, yung height natin ay f of x. And then, yung radius or yung average radius natin, we're going to make use of the midpoint of the rectangles. Pero, ibig sabihin nun, yung radius ay yung nasa gitna nito, which we can just assign as x. Okay, so ito na yung ating integral setup for getting the volume. Now, of course, one less thing to do is to change f of x. Palitan natin siya do sa actual value niya, which is x squared. Okay? Simplify. Factor out ko yung 2 pi. So, meron tayong integral from 0 to 3, and then we have x cubed dx. Sorry, we can now write this pala as dx instead of delta x. Okay, and then perform FTC2. So, we have 2 pi x to the 4th over 4 evaluated from 0 to 3. Now, we can just evaluate this as at x equals 3 kasi at x equals 0, magzi-0 naman yan. So, 2 pi, 81 over 4, simplify. So, we have 81 pi over 2 cubic units. Now, for our next example, so find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is revolved about the line x equals 3. Now, if you would recall, this is one of the examples that we discussed sa previous video kung saan sinolve natin to using disks. At ang nakuha nating sagot last time was 27 over 2 pi. So, let's now use cylindrical shells and check whether we still will get the same answer. Now, dapat ito yung sagot natin kasi same naman yung region na i-consider natin. Now, ito ulit yung itsura ng region. So, ito yung hahanapan natin ng volume. Okay, volume is equal to 0 to 3. Oops. Now, volume is equal to definite integral from a to b 2 pi, height, radius, thickness. Okay? Now, yung ating graph would look something like this. I-revolve natin about the line x equals 3. So, we're going to again make use of vertical rectangles. Okay, with that, makukuha na natin yung limits of integration 0 to 3, 2 pi. Now, yung height that didn't really change kasi yung height ng bawat cylinder dito would still be defined by the distance from the x-axis. So, the height is still equal to f of x, or in this case, x squared. So, yung thickness, delta x, and then, yung radius natin, take note, lumiliit yung radius ng bawat cylindrical shell as we travel along this curve. So, initially, magsisimula tayo sa radius na 3, tapos, paliit siya ng paliit. So, paano natin makukuha yon? So, dito ay 3, and then, babawasan natin siya kapag nandito na to sa part na to. This one again will give us x. Because any point on this graph is defined as x squared. Okay? So, yung radius natin will be 3 minus x. So, radius is 3 minus x. And ito na yung setup ng ating integral that will give us the volume. Okay, so simplifying this one, let's factor out 2 pi. Then, definite integral from 0 to 3. We have here 3x squared minus x cubed dx. Okay, apply FTC2. So 2 pi x cubed minus x to the fourth over 4 evaluated from 0 to 3. Again, all we have to do is evaluate at x equals 3. Kasi at x equals 0, magsi-0 to. So 2 pi 27 minus 81 over 4. So 2 pi 27 over 4. So we have 27 over 2 pi cubic units. So kung mapapansin nyo, parehas yung nakuha nating volume, which should be the case kasi iisang solid lang naman yung kinonsider natin. Magkaibang approach lang. Yung una, gumamit tayo or in the previous video, gumamit tayo ng discs. Dito naman, gumamit tayo ng cylindrical shells. Okay, and for our last example dito sa video na to. So this is again one example that we solved in the previous video wherein ang ginamit natin ay method ng discs. Okay, find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is revolved about the x-axis. So in the previous video, ang nakuha nating sagot was 243 over 5 pi cubic units. So let's keep this in mind when we solve this item using cylindrical shells. Okay, the region again would look like this. Ito yung hahanapan natin ng volume. Okay, so let's analyze how we will set up the integral. So this time, ang axis of revolution natin is a horizontal axis. Therefore, we're going to make use of horizontal rectangles. Okay? So, yung limits of integration natin, doon na tayo sa y-axis titingin ngayon. So, recall ulit natin ang volume. This is from A to B, 2 pi, height, radius, thickness. So, since horizontal yung rectangular strips na ginamit natin, yung ating limits of integration would be from 0 to 9, and yung thickness natin will be dy. Now, we need to get the height and the radius of each cylindrical shell. Okay, so again, since horizontal, may clue na agad na dapat yung integral natin ay in terms of y. So, si y equals x squared, we're going to write it as x equals square root of y. Okay? X equals square root of y. Now, yung height ng bawat cylindrical shell, take note na yung height ng cylindrical shell natin would pertain to this part here. No? This part here. Sorry. Itong part na to. Ito yung height ng each cylindrical shell. So, ibig sabihin, kailangan natin masulat yung height natin in terms of y. Now, technically, yung highest or kapag nandito tayo sa part na to, yung height natin is given by 3. Yung distance from the origin to the line x equals 3. But as we travel up the curve, lumiliit yung height ng cylindrical shell natin. So, dito, mas maliit na, mas maliit, and so on. Na ang nangyayari ay yung 3 nababawasan ng part kung nasaan siya dun sa curve. So, each point on the curve can be represented as square root of y, y. Okay? Now, since yung height natin will pertain to the x value, ibig sabihin, yung height ng bawat cylindrical shell, we can represent that as 3 minus square root of y. Okay? So, ibig sabihin, kung itong cylindrical shell na to ang i-consider natin, this entire thing would be equal to 3, pero itong part na to ay square root of y. Okay? So, yung height is 3 minus square root of y. Now, ano naman ang radius? Ang radius ng bawat cylindrical shell is given by this part here naman. Itong part na to. Okay? Or itong part na to. Or itong part na to. Kasi yung cylinders natin, ang orientation nila ay horizontal. So, itong part na to, this gives us the radius. Okay, so for the radius, that would simply be equal to y. So, we have the height, we have the radius, and we can now proceed with getting the volume. So, the height, again, is given by 3 minus square root of y. The radius is y. Simplify. So, factor out natin si 2 pi. Then we have definite integral from 0 to 9 ng 3y minus y raised to 3 halves dy. Apply FTC2. So 2 pi 3 halves y squared minus 2 fifths y raised to 5 halves, evaluated from 0 to 9. Now again, all we have to do is evaluate at y equals 0 kasi at y equals, at y equals 9 kasi at y equals 0, that would just be equal to 0. So at y equals 9, this is equal to 2 pi times 3 halves times 81, which is 9 squared, minus 2 fifths. Y is 9, but 9 is 3 squared. So, pwede natin i-cancel yung 1 half sa exponent. So, we have 3 to the 5th. And simplify further. 2 pi. This one is 243 over 2. And then, ito naman ay 2 fifths times 243. Or 2 pi 243 over 2 minus 486 over 5. Simplify further. So again, dapat careful tayo sa ating arithmetic dito since we're going to be solving a lot of definite integrals, no? Now, technically, ito ay 243 times 2, no? So, we can factor out 243. Then, mas madali na 1 half minus 1 fifth. Minus 2 fifths, sorry. So, 486 pi. 1 half minus 2 fifths, that gives us 1 over 10. Simplify. So, magiging 5, magiging 243. So, 243 over 5 pi cubic units. Okay, so this is our last example for getting the volume of solids of revolution using cylindrical shells. As you can see, this is just an alternative method. Pwede kayong mag-washers, pwede kayong mag-discs, pwede kayong mag-cylindrical shells. As long as parehas or as long as tama yung pagkaka-execute nyo, you will arrive at the same answer. Now, depende na lang kung sa instructions naka-specify which method to use. But if not, you can use any method or kung ano yung mas preferred nyo. Okay? So this is the end of this video for volume or for getting the volume of solids of revolution.